is week 1, so session 1 if you like, of the Resits Foundation GCSE course. So under, I guess, the big banner of number, we're looking at structure and calculation. Now this should feel quite easy. So it should feel easy. It's the topics that you cover right at the start of secondary school. So we're looking at, addition, multiplication, the order that you do it in, mainly for the non-calculator, because in a calculator exam, as long as you type things exactly, including your brackets, you will be absolutely fine. Right. So you will have heard of BIDMAS, BODMAS, that gives you the order of operations. Now that's if you have to put brackets in. So we know that we do our brackets first, our indices, then division, then multiplication, addition, and subtraction. We then have some symbols. So I don't know how you've ever learnt them, but you've got your greater than and your less than. And all you do is as if you were reading from left to right. So X, there's the small bit of the arrow, is smaller than Y or less than Y. And in this case, we're reading left to right again, X, the open mouth is there, greater than, because it's the bigger bit, Y. So it's as if you're reading it. If you've got a second line there, it's equal to as well. So it's just giving you, so you need to know those symbols. We then come into talking about things like factors, factors and multiples. So if something is in the times, if there is a number in a times table, so for example, 8 is in the 2 times table. So 2 is a factor of 8. And also you have multiples. So that's if you multiply a number by something, what you get is a multiple of it. We look at highest common factor and lowest common multiple. We'll look at these as we do questions, because there's questions in all the papers. There's numerous ways to do it. You might have done it using a factor tree. You might have done it using Venn diagrams. I'm going to show it to you using fractions, but whichever method you use, it doesn't matter, right? The answers are going to be the same. And then we have indices. With indices, we've got our main rules. Essentially, you're going to remember the letter, which we've used A here, or the number, which will be a number, is called your base. Now, you can only use these rules if the base is the same. So if you're dividing, you take away. If you're multiplying, you're adding. The thing you have to remember, and students always get wrong, anything to the power of 0 is 1. A gazillion to the power of 0 is 1. It doesn't matter what it is. If it's to the power of 0, it's going to be 1. And slightly trickier, and would only ever be towards the end of the paper because it's going into the sort of the higher grade, is when you have a negative indice, which represents 1 over. But again, when we look at some questions, this will all come together. Standard form, I'll show you how to use it on your calculator, but you're just counting the jumps, because it's just multiplying, and is multiplying by 10 or dividing by 10. Okay, so let's have a look at the non-calculator questions first. Now, this is a question 9. This is towards the end. I'm not quite sure why I've put it first, but it's towards the end of the exam paper. So you're not going to worry about this question too much. This was one of the questions that will be on the higher paper as well as the foundation paper. So you've got 36 to the power of a half. On that crib sheet up above, we've got anything to the power of a half is always square root the number. So you're going to have a look at that, and you're going to make sure that if you square root 36, you're going to get 6. Okay. One of your other rules, if you've got anything, so here we've got to the power of 0, is going to always be 1. So me to the power of 0 is 1. We could have 1,000, 2, 3, 6, 7. Doesn't matter what it is. Anything to the power of 0 is always 1. And remember, a square root means what times what gives you that number, right? This would be on a higher paper, so we're not going to worry about that question. unless we want to try going for full marks. Okay, so now we're going to think about factors. Okay, factors. So remember, which one was factors? Was it the smaller one or the bigger one? So you're going to say, okay, the smaller one is what factors is. So factors is everything in which 18 is inside its times tables, right? So you just have to think about it. You're going to go, okay, is it in the 1 times table? Yes. 1 times what gives me 18? So 1 and 18. Is it in the 2 times table? Well, it has to be because it's an even number. Remember, even number ends in 2, 4, 6, 8. So because it ends in one of those numbers, we know it's 2 times something. So what is it? Hopefully we got that 2 times 9. So every time you know one of them, you also know your other value. Right, now let's go up 3. Is it in my 3 times table? Now a trick, if you have a longer number and you want to know if it's in the 3 times table, you can add up the digits. So if I do 1 plus 8, I get 9. Now 9 is really high up in the 3 times table. So I know that 9 is in the 3 times table, 18 is in the 3 times table. So 3. And I don't know whether anyone's ever taught you to put your fingers down. You can figure out where, how many, but hopefully we know that, you know, how to get 18 from 3. That's for your 9 times table. Sorry, ignore me, not 3 times table. But that would have given you your 9 times 2. So 3 and 3 times what gives you 18? 3 times 6. Okay, so that's literally just looking at your times tables, which I know you maybe sang when you were little, but they're one of those things that you just need to know. And if not, just scribble them down on the side. If you're like, you know, if you learnt them as 2, 4, 6, 8, 10, and you have to think about to get to it, just scribble some numbers down. You can write as much as you like, scribble all over the paper if you have to. Okay, so now we've got a standard form question. Okay, important rule. You need to find the number between 1 and 9. In 1 and, you know, 10 if you like, but not including 10 in this. So we're like, okay, where is the number? The number is here. You got 97. Now that's too big. How do I get it between 9 and 10? I'd stick a decimal place there. So that's your first step. So the only way to do that is to put a decimal place there. So we put that in 9.7. And then we count. And we're going to do 1 jump, 2 jumps, 3 jumps, 4 jumps. So I've done 4 jumps backwards, right? So 4 jumps to the left. So I'm going to do times by 10. And because it was backwards, it's a small number, minus and how many jumps I did. Okay. Again, these are like, as you can see, questions that are towards the end of the paper, because to be honest, a lot of the number stuff is multiplying and dividing, which we will look at when we do a full foundation paper if it's at the start of it, but they're only worth a few marks. So this is the bit which gets you from that level 3 to getting your pass, you know, to getting you through to the level 4, 5. So some of these might be tricky and also in the higher paper, but if you know the rules and you can do them, you should be okay. And if some of the basic functions still you find difficult, what you need to do is go look at videos very particular to them. So if you're still confused about, or you struggle to multiply, doing long multiplication, just have a look at a quick long multiplication video. You'll never have to do probably something so big. It'll be no more than what we've done in some of these questions, but it's okay. Have a look up a long multiplication video, put something in the comments going, I can't do long multiplication, and maybe we can make a really short video for you. But generally this first topic, I'm hoping should feel relatively easy to just read through the notes. But then some of the questions we're doing are on the trickier side because that's how they test it. Yeah, they're very mean when they come to these. Right, so now they're saying, work out these. Now there's 2 ways to do them. If you are comfortable with the indices, we could do them using indices, or you can just work them out in full. 3 times 10 to the 5. So whatever number right? If that's a positive number is after that, it just means that you either move the decimal place, there's none of them, or you add that many zeros. So we're adding 1, 2, 3, 4, 5 zeros. And on the bottom here, we're taking the 4 and we're adding 3 zeros, okay? Because you're timesing it by 10, then timesing it by 10, then timesing it by 10. Now we can cancel out the zeros. So there's a 0 on the top, we can get rid of 1 there. There's 1 there, we can get rid of that. That one, we could get rid of that. And then we've got 300 divided by 4 left. Okay, it's always easy to half. So let's half it first, okay? So 300 halved is going to give us 150. And then we've got it over 2 because 4 halved is 2. And then dividing by 2 is the same as halving. And we're going to half again. Now, halving is a trick that you should be quite good at or should get quite good at. So if you think about it, 150 is made up of 100 and of 50. Yeah? Half of 100 is 50. And half of 50 is 25. I add those up and I get 75. So as an ordinary number, my answer is 75. Yeah, okay. Right, let's think about this one. We've got 4 positive whole numbers. Okay, we can do that. 3 marks, so I'll show you how the marks come up as well. So first of all, we know we can't have any negative numbers. We know that they add up to 84, okay? One of the numbers is a multiple of 17, all right? So let's think, what does multiple of 17 mean? It means something in the 17 times table. So 17 times 1 is 17. 17 times 2 would be, 17 plus 17. Yeah, or we could do the doubling trick. So we'd get 34. And then times 3, we'd have to add another 17. So you do 7 plus 4 to give you 11. And then 3, 4, 5, 51. And I could have another 17, 8, 68. But we're probably going to see that at some point we'll leave those there for the moment. And we'll say, okay, and the other 3 numbers are equal, right? So when we then take away whichever value we use, we're going to have 3 numbers left, which are going to give us something that's equal, right? So what we're going to think about first, well, if we're taking away 17 or 34 or 51 or 68, we want to be left with a number that divides by 3, because there's only going to be 3 numbers left that we have. Now, this is a positive number. Oh, so here, 84 is a positive number, right? Okay, well, we can just try a few. That might be the easiest thing because there's only a few here. You can do 84 minus 17 minus 17. So you're going to do, that's going to give you 67. That doesn't go in to 3. Remember our trick? We can do 6 plus 7. Definitely doesn't go into 3. Right. 84 minus 34. 0. 50 doesn't go into 3. 84 minus 51. And now equals 3 and 3, 33. Yes, that's one of the easiest times table. That's our 11 times table. So 33 divided by 3 we know is 11. So therefore we know our 4 numbers must be 51, 11, 11, and 11. So what you might find is if you've seen this question before, then maybe somebody's done some algebra, 17x plus 3 something equals this. It doesn't matter. Just think about it logically. No one's telling you need to know your 17 times table. You just need to be able to work it out. So you need to add quickly and subtract. And even not even that quickly, it's 3 marks, which means you've got 3 and a bit minutes. So you've got kind of double, or 4 and a bit minutes, you've got double the time that it's taken me to do it. So you've got enough time, just go slow, think it through and think logically. Okay, as you can see, end of a paper again, we're at indices. So remember, indices again is the more difficult bit. If you're a bit worried about it, we've got a whole separate video on indices and we're going to go through those slowly, but you're going to think of the rules. Okay, so I will put this document up. I'm going to edit the rules so they're a little bit clearer to see. But essentially, when we times, our brain is going to go add the indices. Okay, so we've got M, so we've got 3 plus 4. So that's 3 plus 4 gives us 7. Now here we've got, let me rewrite it bigger, 5np cubed. So that's actually to the power of 3. So we're doing 5 to the power of 3. Remember, that doesn't mean 5 times 3. It means 5 times 5 times 5. So everything in the bracket is to the power of 3. So first we're going to do 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is going to give us 125. Right? And you can write that out, like I said, as a long multiplication if you're not sure. If you didn't know that or you needed to check it. Not a problem. You can write your little multiplications wherever you like. So now we know that's our first bit. Then we've got this bit here. We've got n. Oh, I don't know what's happening. We've got n to the power of 3. So we've got n times n times n. That's just n cubed. And then we've got p cubed cubed. So that's like saying p cubed times p cubed times p cubed. Now remember, when we times, we're adding. So it's the same as saying 3 plus 3 plus 3, or 3 times 3, which is 9. Okay. Right, next one. It says simplify, and that looks disgusting, but we're going to break it down. It's not actually that horrible. They're actually quite nice to do. Okay, so we've got 32. Just take the numbers on their own. You're going to do 32 divided by 4. So what is 32 divided by 4? So that's going to give me 8. We've got q to the 9 over q cubed. So you've got q to the 9 over q cubed. Now, the thing to remember is a fraction is just a fancy word of writing divide. Okay, so q to the 9 divided by q cubed. Now, in our rules, divide is the same as take away. So we're going to do q 9 take away 3. And so we get 9 to the 6. Now, the reason is q to the 9 is q times q times q, 9 times. 2, 3, 4, 5, 6, 7, 8, 9 over 3 times. And remember, anything that's the same on the top and the bottom, we can get rid of. So get rid of 3 of those, get rid of 3 of those, and we're left with 6. So that's q to the 6. So you just break it down into little sums. And then we've got r to the 4 over r. Now, r just means r to the 1, because we never bother writing the 1. So it's the same as having a 1 here. So we can do 4 take away 1, and we get 3. So we've got r cubed. So we've got 8q to the 6 and r cubed, right? Okay, so now we've got lowest. So remember, we had the highest common factor. We've now got the lowest common multiple. And again, I'm going to show you how to do it using the fraction method, where you cancel down a fraction, but also using prime factorization. Okay. Oh, sorry, it doesn't say highest common factor. It says lowest common multiple. Ignore me. It's exactly the same as the previous question, but we're going to do it both ways again anyway. So we've got 40 over 56, and we want to simplify that. Okay, so those aren't numbers that I easily know what times table they go in, but I can see they're both even. So that means I can half them both. Half of 40 is 20, because half of 4 is 2. Half of 56, I'm going to do 50 divided by 2, which is 25. 6 divided by 2, which is 3. Add them up and I get 28. Half it again, because still even numbers. I'll get 10 and I'll get 14. I could even half it again and I get 5 and 7. Okay? And now it's in simplest form. So let's say 40 over 56 equals 5 over 7. So if you remember, what we did is we took the diagonal. It doesn't matter which diagonal you take. You could take 56 and 5 or 40 and 7. I'm going to take 40 and 7 because it's easier, like just from a multiplication perspective. 40 times 7, 7 times 4 is 28. Add the 0, I've got 280. And that is my lowest common multiple. So that's using that fraction method. If you have learnt and what makes sense to you is prime factorization, you may have done it like this. 40, what's the prime factor? So the first prime factor we're going to go with always is 2, which we can half. And we can do 2 again. And we can do 2 again. And we've got 5. And we've got our prime factors. 56, we're going to do the same thing. Half it, which we did up there anyway. Half it again. So this is essentially what we've been doing. Half it again. And we've got our prime factors. And we say to ourselves, let's see what's the most amount of 2s we've got. So, or if we have a look, let's see, there's a 2, 2, 2, 2. So we've got 3 2s, 1 5. So we've already counted the 2s. So we've got to add the 7. So we would do 2 times 2 times 2 times 5 times 7. So essentially 40 times 7, which we did above, to give us 280. Okay. Highest common factor works in a similar way, but this time they've done the prime factorization for you. So what they've done is they've already split it. Now for the highest common factor, if it's in prime factorization, what you're going to say is what's the same? So let's see, what do they have that's the same? Well, we've got 3 2s here and only 2 2s here. So we have to take the smaller amount this time. Okay, we've got a 3 here and a 3 here, so we can take 1 3. We've got 1 5 and 2 5s, but we just want 1 5. And we'd multiply that. So 2 times 2 gives me, so let's do it in bits. 2 times 2 is 4. Then we can times it by 3, which gives us 12. And then we can do 12 times 5, which we should know is 60. And so our highest common factor is 60. Okay. So I'm hoping that's made sense. So you want to find the value of the square root of 1.44 times 3. And you just make sure that what you see in your calculator screen is exactly the same. I have just realized this is like twisted around. So hopefully this fixes it. Let's try this. Stop video. Yeah, okay. So hopefully this is the calculator you have. You may have it, you know, it doesn't have to be in pink, obviously. So we're going to try scroll down. So you're going to write square root button. And you want yours to look exactly like that. 1.44 times 3.61. So your calculator display should look exactly as the display, what it tells you in the question before you hit the equal sign. If it doesn't, then you're going to get the wrong answer. So then I'm going to hit the equals button and it gives me 57 over 25. Now that would be fine, but because the question's in decimals, we want to give the answer in decimals. So we're going to press the S to D button and it gives me 2.28. And that's my answer. Okay, so if we use the next one, which looks, you're just going to make sure everything, you type in exactly as it gives it to you. So open bracket, 3.54 minus 0.96, close the bracket, squared, minus 4.096. So it looks exactly like it does on the screen. We hit the equal sign, we get an answer, and we write that answer down. Right, so 2.5604. The next question's from paper 1. So now we're in non-calculator world. And so we're going to be manually doing the calculations. Right, we've got Fahima buys 2 packets of bread rolls, 1 bottle of ketchup. We ticked how much money she spent and what her change was. And we've got some information missing. So let's work through it. We've got 2 packets of bread rolls for £1.50 for each packet. So altogether, your bread rolls are going to be £1.50 times 2. So you know that that's going to be £3. And then we've got our ketchup, which is £1.60. So altogether, that gives us £4.60. Now, she's paid with a £10 note and she's got 30p change, which means she must have spent £9.70. Now, if we minus the £4.60, we're going to get £5.10. Now, that's for 3 packets of sausages. We want to work it out for 1. So we're going to take that £5.10 and we're going to divide it by 3. 3s into 5 go once with 2 remaining. We copy the decimal place up. 3s into 21 go 7. So we get £1.70. So she said it was £2.30. Is she right? No, she is not correct. And if your working is nice and neat, you wouldn't need to write anything more. But in case it's not clear, you'd say each packet is £1.70. Right, the next question. You've got 31.7 times 100. Now remember, when you times 10 or by 10 or 100 or 1,000 or any factor with a 0 there, the number of zeros tells you how many zeros you're adding or how many places you're jumping the decimal place. So we're jumping the decimal place 1 and then 1 more. So we get 3170. Right, next question. We've got Alan, Bispa and Chan share a sum of money. Alan gets 1/8 of the money. Bispa gets a half of the money. Chan gets the rest of the money. And Alan gets £2.50. Work out how much Bispa gets. Okay, so we know that 1/8 is equivalent to £2.50. So if you like, 1/8 is in a ratio of £2.50. Now, we are trying to work out what a half is. Okay, so if we want to make it so it's got an 8 on the bottom, we know 1/2 is the same as 1/8 times by 4, because 4 over 8 cancel down to a half. So if we know 1/8 is £2.50, we can work out a half by doing 250 times by 4. When we double £2.50, we get £5. Double that again, we're going to get £10. Then it says, find out the ratio of the amount of money Alan gets with the amount of money Chan gets. Okay, so there's a few ways to do this, but we can work out, we know Alan gets 1/8, Bispa gets a half, which we said was 4/8, so altogether that's 5/8. To make a whole, we need 8/8. So 5, 6, 7, 8. So therefore, it means that Chan is getting 3/8. So we're saying Alan gets 1/8, Chan gets 3/8. So the ratio is 1 to 3. Right, find the value of the reciprocal. Reciprocal, you see that word, you're doing 1 over. So you see this, your brain is going to go 1 divided by. Now, it's paper 2, you can use your calculator. 1 divided by 1.6. In your calculator will automatically come up as 5/8. Because it says give your answer as a decimal, you're going to press that SD button and you do it. You will get 0.625. Okay, so I hope those have been useful.